Hello everyone, welcome to my channel, and my name is KenMath. And if you are new to my channel, please don't forget to subscribe and hit the notification bell, and don't forget to comment, like, and also share the video for you to support this product, or for you to support this content. Okay, so in this video we are going to talk about finding stationary points by differentiation. So finding the stationary points by differentiation, those are the things that we're going to talk about. So they say when you find the stationary point, you have to find the second derivative, or the second differentiation coefficient. That is what we're going to find. So when you're finding the second differentiation coefficient of y with respect to x, is written as d to the power 2 of y over dx to the power 2. This is the second differentiation coefficient. So the differentiation coefficient is written dy over dx. That's the first one, which says that the nature, they say that of this one, or the gradient of a tangent to the curve, which is y is equal to function of x, is given as dy over dx. So that's the reason why they say for a stationary point, the dy over dx is always equivalent to 0. So it is always equal to 0. The dy over dx is always equal to 0. Now, there are some times whereby you find that if the dy over dx is greater than 0, then the function y, the function y is equal to function of x is increasing. They say it is increasing. Why is it increasing? Because the dy over dx is greater than 0. So that's the reason why it increases, because it is greater than 0. And then the other thing that they say is that if the dy over dx is less than 0, if the dy over dx is less than 0, then the function, which is y is equal to the function of x, is decreasing. That's how it is. So those are the things that we're supposed to take note of. And then for a stationary point, then the dy over dx is equal to 0. These are for a stationary point, these 4 points. So the dy over dx is equal to 0. And then if you find the second differentiation coefficient is less than 0, then those points, therefore, they are maximum points. So if the dy over dx is greater than 0, it is less than 0. Those are the points for the maximum point. And then if the dy over dx, the second differentiation coefficient, is greater than 0, those points, therefore, a minimum point. Let me repeat that. So if the second differentiation coefficient is less than 0, those points that you have found, for the stationary points that you have found, are the maximum point. They are maximum points. And then if the second differentiation coefficient is greater than 0, then those are the stationary points that you found. They are for minimum point. That's how it is. But if you find that the second differentiation coefficient is equal to 0, then possibility of a point of infiltration. So they are possible that it is the point that in infiltration. That's how it is. So these are the 4 points that you're supposed to take note of. Okay, so here they have given us, they have said, find the stationary points of the curve, this curve, and state the nature of the point. So they want us to state the nature, if it is maximum point or if it is minimum point. So that's the nature of the point. That's they want us to find. So the first thing that we're going to do is, first of all, find we have to find the dy over dx. Then the original dy over dx, not the second, but the first dy over dx of this function. That's what we are supposed to find. We all know that the nature, the stationary point is always, the stationary point is y of dy over dx is equal to 0. So let's do that. So we're going to say the dy over dx over is equal to the derivative, the dy over dx of a single of a constant number is 0. The dy over dx of negative 2x is negative 2. And then the dy over dx of 2x squared is negative 2x. And then remember that these are stationary points. So these stationary points, they are always equal to 0. So they are equal to 0. So if these stationary points, they are equal to 0, then we have to find the value of x. How do we find the value of x? We're going to group the like terms. So we're going to say negative 2x is equal to positive 2. So negative 2x is equal to positive 2. Oh. Okay, so the dy over dx of a constant number is 0. The dy over dx of x of negative 2x, it is negative 2. Negative 2. The dy over dx of negative 2x squared, we're going to use the power rule, which says that it's negative 4. We multiply this power multiplied by the coefficient, which is 2, negative 4, and then x from this power we subtract 1, so it gives us the power of 1. So this one. And then we have to know that the stationary point of dy over dx is equal to 0. So it's equal to 0. This is what they have said here. So the dy over dx of stationary point is always equal to 0. And then from there we have to find the value of x. So we're going to find the value of x by grouping the like terms. So we're going to say negative 4x is equal to negative 2 crosses this sign, changes to positive, so positive 2. And then from there we have to find the value of x. So we divide by negative 4, even this side we divide by negative 4. So negative 4 cancels, which gives us x is equal to negative 1 over 2. These are the values of x, so negative 1 over 2. So we are going to say the point that we have, x is 1 over negative 2. That is for the first point, which is the point of x. Now for us to find the point of y, we're going to use the original equation. So we're going to say y, let me use the other one, that color. So we're going to say y is equal to 1 minus 2, where there is x, we will replace with negative 1 over 2, negative 1 over 2 close, and then minus 2, where there is x, we replace with negative 1 over 2, and then we close, and then there is a square on top. So when we do all this, stuff, it will give us 1 over 1 over 2. 1 as a whole number, 1 over 2 as half, 1 and half. That's what it will give us. So y is equal to 1 over 2, which is half. So these are the points, the stationary points that we have. So this is how we usually find the stationary points of a given curve. Now, for us to test for nature of the stationary point, we're going to use the second derivative. So we're going to use, this is the second differential coefficient. That's what we're going to use. So the second differential coefficient of that, this is the first one. Now we are going to differentiate this one the second time. So we are going to say the second differential coefficient, we're going to say it is the d squared y over dx squared. And then of what? Of we have been given of that. So negative 2 minus 4 x. That is the first differential coefficient. That was the first one. So say the y d to the power 2 of y of dx to the power 2, which is the second differential coefficient, is equal to, when you differentiate this one, it will give us 0. When you differentiate this one, it will give us -4. So the d over the second differential coefficient is equal to -4. So if the second differential coefficient is equal to -4, we are going to check here. We're going to see. So here, the second differential coefficient, if it is less than 0, meaning maximum point. If it is greater than 0, minimum point. So we are going to say these points, the fact that this one, we are going to say this one is less than 0. So if this one is less than 0, because it is surely less than 0. So less than 0 because the dy over dx, which is the second differential coefficient, is -4. So the second differential coefficient is -4, meaning it is less than 0. So it is less than 0, meaning that the points which are -1 over 2, 1.5, this point, it means that this point is a maximum, that point is a maximum point. So it's a maximum point. Why is it a maximum point? Because the second differential coefficient of these 2 points of this point, I mean, is -4, which is less than 0. So that is why it is the nature is a maximum point. So if it gave us the greater than, for example, if it was above 0, then you would have said it's a minimum point. That's how we usually find the nature, and that's how we usually find the stationary points. So these are the 2 stationary points here. That's how we find the stationary points and also the nature of those points. That's how we usually find. If you have got a question, please don't forget to leave them on the comment section below, and like this video, comment, and also share the video, and subscribe to my channel for more content.